This is a short video on differentiation from first principles. The first thing to note before we begin is what differentiation actually is. Differentiation is a way of finding slope. Now, we last came across slope in coordinate geometry, and in coordinate geometry we use certain techniques to calculate slope. We can find it by using rise over run, or we can use our formula m equals y2 minus y1 over x2 minus x1. And we use this formula because generally in coordinate geometry we have points and we can use the points to sub into the formula and we get our answer. But differentiation is used under different criteria than coordinate geometry. We want to be able to find slope even if we don't have all the points that we might have in coordinate geometry. And so differentiation allows us to get slope if we have a function, and we can evaluate if we have a point as well. We might even be given a point, though we might just have the function itself. And what's really happening in differentiation is that we're adapting that m equals y2 minus y1 over x2 minus x1 formula from coordinate geometry to suit our needs, where we don't have all those points that we might have from coordinate geometry. So what we're imagining is that we have some function. I've drawn a quadratic, and we have 2 points on the function. We don't even have numbers for these points. We think of one of the points as being called x f of x, and we think of the other point as being called x plus h, f of x plus h. And h is just the horizontal distance between the 2 points. And what we want to do is we want to squeeze this h down by bringing this second point, x plus h, f of x plus h, closer and closer and closer into our x f of x point. So I'm bringing that point in closer and closer and closer to x f of x. And what I'm really aiming to do is to make the x plus h, f of x plus h point sit on top of the x f of x point. So really what I'm doing is I'm squeezing down the distance between them until it's 0. In this case, I'm going to call my derivative f dash x. Because differentiation really means slope, f dash x is just another way of writing slope. And I'm going to want to use the 2 points that I spoke about earlier in the formula for slope. But I want to squeeze the h down so it's literally nothing. So I'm going to write in the very beginning of the formula that I'm going to want the h in the formula to turn into a 0. And this is achieved simply by writing the limit as h goes to 0. The x1, y1 and x2, y2 for my formula are going to come from these 2 points. And then I'm going to fill in, and that's going to give me the limit as h goes to 0, f of x plus h minus f of x over x plus h minus x. That's just me substituting into this slope formula from these 2 points up here. I could even tidy this up a little bit more, because the x's in the bottom will cancel out, leaving me with just a h in the bottom. And this is the formula that we're going to use then to do our first principles differentiation. All the stuff up to this point is why this formula works. When you're doing a question in your book or from exam papers, you're going to be looking to apply this formula. But it's good to understand where it's coming from. The formula is not in the log tables. You do need to know it. And you'll only use it if the question specifically asks you to differentiate from first principles. If they don't mention first principles, then you won't need to use this. So what does a question look like in practice? Well, here's an example. Differentiate from first principles, f of x equals x squared plus 5x minus 2. A couple of things to point out here. They mention first principles. I have to use this formula. Second of all, they've called it f of x equals, and there's my function. Just bear in mind, this could just as easily be called y equals x squared plus 5x minus 2. Remember that y and f of x are the same thing. Okay, so I want to use a formula, so I'll start by noting the formula. So I've made a note of it now. And it's a pretty clunky formula. There's lots happening in it. So to make things a bit more straightforward for myself, I'm going to do it bit by bit. I'm going to first of all make a note of f of x. That's what they gave me in the question. Then I'll make a note of f of x plus h. I'll do any tidying up that's necessary, and then I'll fill it into my calculation. So f of x is just exactly what I was given, x squared plus 5x minus 2. Now I'll make note of f of x plus h. To get f of x plus h, I'm literally just going back to my original function and replacing all the x's with x plus h's. And I should just make sure to put them into brackets as I fill them in. Take care to tidy this up properly. So pause the video now and do that, and then play and check and see if you got what I got. So this tidies up to x squared plus 2xh plus h squared plus 5x plus 5h minus 2. And now I'm ready to go and put all this information back into my formula for f dash x. So I'll start by writing down f dash x equals the limit as h goes to 0. And I must, once I begin to form the formula, write this limit as h goes to 0 down until I get to the stage where I actually fill in zeros for h, at which point then I can stop writing it down. So I'm going to fill in my f of x plus h. Then I'm going to minus my f of x. Now just take care that because f of x is more than one term, I must put it in a bracket as I subtract it. And the whole lot will go over h. Okay, so a bit of tidying up is clearly necessary on the top. And again, pause the video here, tidy it up and see, do you get what I get? So once you tidy up your numerator, here's what you should be left with, 2xh plus h squared plus 5h over h. Now at this point you might be tempted to fill in your 0, but that isn't a good option just yet because there's a h in the bottom. And if I fill in 0 in the denominator, well, I'm not going to be able to work out a solution. So what I need to do first of all is see, can I do any further simplification? Now you might notice that each of these terms here has a h in it, so I can factorise out that h. And why might I do that? Well, by doing that, I can now get rid of the h in the bottom by cancelling it against the h that's been factorised out of the top. So I'm left now with the limit as h goes to 0 of 2x plus h plus 5. So now at this point, when I've simplified everything that I can simplify, there's nothing further that I can do inside my brackets. This is the point at which I apply my h goes to 0. And all that means is that on the next line, any h's that remain will get turned into zeros. So I end up with 2x plus 0 plus 5. And so my final answer, f dash x equals 2x plus 5. Just note that although this is slope, it doesn't look like a typical slope that we get in coordinate geometry. There's an x in it. It's not just a number. The reason for this is that if you look back earlier in the question, what we were trying to find the slope of was a quadratic. That was our x squared plus 5x minus 2 that we began with. If we visualize this function, it's a curve. So clearly, depending on where we are in the curve, we're going to have different slopes. Here on the left, I'm sloping down, but even at these two positions, the slopes are different. Once I pass the turning point, I'm then sloping up, and it's getting steeper and steeper. So the x that's present in my result is allowing for that. So depending where I am on my function, I can look up the x value and stick it in and work out the slope at that particular position on the curve.